Hey guys, hope you're having a good day. We have a couple other trig functions that we need to tackle with this video, okay? And so, going to be kind of a combination of the sine, cosine, tangent, and cotangent functions that we've had in a previous video or that we had in class, whichever way we saw it. So first up is cosecant. I'm not a big fan of graphing cosecant. So what I like to do is I like to take out this cosecant and just act like it's sine. Now I'm just going to act like it's sine, so I'm not really going to graph sine, but I think sine is going to help me get to where cosecant is. Because remember with sine I got to start right here at the origin. And I got to just sit there and oscillate between 1 and -1. And so we came up, and we came down, and we came up, and we came down. That was the good old days. Remember these, were how easy these were? And that was my sine function. Once I completed one full period, one full hill and valley, I was at 2 pi. And so we labeled all of these points. Now, since cosecant is just the reciprocal of sine, I'm hoping that sine will help me graph cosecant. Well, remember what happened in the last video with tangent and cotangent. When I had something on bottom and equals 0, it gave me vertical asymptotes. Everywhere that the value came out to be 0 on bottom, boom, I had a vertical asymptote. All right, well, I know where sine's equal to 0 at. Sine is equal to 0 everywhere this blue line crosses the x-axis. Now I've got way more asymptotes than you're going to have to draw, but I do want to show you that this graph just does go on forever and ever to the left or to the right. Okay. Now to graph the actual cosecant function, which is going to be the reciprocal of sine, I could show you this with the table, but it's just so easy. All I got to do is put a little dot on these hills and valleys and draw a U on all of them. Even these over here on the negative side. And so these U's right here are actually my cosecant graph. Everything else that's a dotted line on here is helping me graph cosecant. It's not really there. So we end up with these U's. I had a student, it's at the Naval Academy right now. She's majoring in math, and when she took this class years ago, she always called these Lego hands. It looks like a little guy right here, and he's got his Lego hands going up and down. I can't really draw a Lego guy very well, but if you guys were in class, my son's in here, he can see me do it. He'll verify. It looks like Lego hands, right? All right, where the body is the vertical asymptote. I think we talked about it in one of my classes last week. So I don't want all this information over here on the side. Let's kind of work our way from the bottom. As you can see, the vertical asymptotes are going to be at every multiple of pi going down through here. And so on the parent function, every multiple of pi. It still takes 2 pi to complete a Lego hand going up and a Lego hand going down. Stretch factor, domain, range, phase shift, vertical shift, I'm going to have all that come out in a table just like we did sine and cosine, because this is what our graphs are going to look like. I'm going to graph sine in order to help me with cosecant. All right, so this is my second go at this example. I guess I changed numbers about halfway through and didn't write it down for myself. So I'm wanting to graph y equals 2 cosecant of pi x plus pi over 4. I'm hoping this video works twofold. I'm hoping that it helps you graph sine and cosine better, because I know that there's still people out there struggling with that. And then we're able to learn from that how to graph cosecant and secant. So first order of business is I'm going to act like this is his brother sine instead of cosecant. If it's his brother sine, then I know good and well that the amplitude is going to be 2, The period's going to be 2 pi divided by pi, which is 2. All of that is helpful in helping me graph this. And so remember what we did was we made an XY table that had 5 points in it. The very first point right here is supposed to be 0. Remember, sine likes to go from 0 to 2 pi. And so if I take everything that comes with the x right here and set it equal to 0, I subtract pi over 4 from both sides, and then I divide by pi. I'll no longer have a pi, but rather I'll have x equals negative 1/4. And so that's where my table is going to start. My table liked to end at 2 pi. But since I have a period change and I have a phase shift, it's not going to end at 2 pi unless I just get really lucky for some reason. And I'm not going to right here. I'm not that lucky of a person. Okay, so whenever I subtract pi over 4, that's going to give me 7 pi over 4. Divide both sides by pi, it pretty much just vacates the whole thing from having pi. Meaning that your x's do not have to have pi in it. I explained it this way to somebody. You're either going to have a pi right here, or you're going to have a pi down here in your table. Now, 6th hour, pay attention to this because I taught it this way in 7th hour the other day and it went a lot better. I tried to teach it this way to you guys and it just kind of flopped around. So remember, I can divide this period by 4 and I can just move up by increments of 1/2, which wouldn't be hard right here, but I think there's an easier way. What I can do is I can think of the nicest number I can between -1 and 7. I'm not going to think of the nicest number. Sorry, I said that wrong. The halfway between -1 and 7. And so halfway between -1 and 7, let's see, 7 minus 1 is 6. Take half of that would be 3. Would be 3/4. So instead of dividing by 4, I can just do what I call half-seas twice. I can go halfway between -1 and 7, and then I can come in here and go halfway between -1 and 3. Halfway between -1 and 3 is +1. And halfway between 3 and 7 is +5 over 4. And now I have all of my nice x values on this table. If that didn't make sense, hit pause, go back and watch it again. Okay? But the idea now is that if I take this -1/4 and plug it in for x, let's see, that's going to give me -1/4 pi plus pi over 4, which is 0. And remember, I'm doing sine of 0, not cosecant yet, which equals 0, times this 2 in front, which gives me 0. Hey, DHS shortcut right here. If you feel confident about that number, you can put it on top and bottom. It'll always be the same. Let me do that again and maybe spell out a couple more steps in case you didn't follow. So now I'm going to plug in +1/4 in for x. That gives me 1/4 pi. I'm going to add that to pi over 4. I'm going to take sine of that angle, and then I'm going to multiply it by 2. So pi over 4 plus pi over 4 is pi over 2. Right off my unit circle, or regular calculator. Sorry, Jared, we're going to go regular calculator on this. We're going to get 2 times 1, which gives me 2. So up to 2 right there. If you didn't quite get that, I'm going to do it again. I'm going to plug 3/4 in for that x. So 3/4 pi minus a pi over 4. Take sine of that, and then multiply it by 2. So it's just, I'm just plugging and chugging right into this equation right here. So 3 pi over 4, take away a pi over 4, that's 2 pi over 4. Oh, I'm adding, sorry. That gives me 4 pi over 4, which is just pi, what I have written down. Yeah, that's what I meant to do. And I get 0 right here. DHS easy button number 2. If you're working with sine, whatever you get here, you'll also get here, and you'll also get here. Only if you're working with sine. If you're working with cosine, It's got a little bit different pattern that you might have caught on to whenever doing the homework last week. I have one more number to plug in. That's right, I'm going to plug 5/4 in for this x. So I got 2 sine of 5 pi over 4 plus a pi over 4. Well, that gives me 6 pi over 4. I can reduce that to 3 pi over 2, which is just going to be 2 times -1. I get a -2. All right, I'm ready to write all these down. Keep them all equally spaced. So on my graph paper, I'm just going to label the points that are on my graph. Okay, so 1, 2, 3, 4. So it looks like I'm skipping one line between each one. Sorry, that's really small. 7/4 right there. Scale your or your y-axis for me. So I'm just going to call this 2. I'll come down to -2. So I plot all my points, connect the dots, and I have my sine function. Continue this same pattern for one hill and one valley off each end. So I get 2 hills and 2 valleys. And we're done, right? Circle it. Mr. Loveley's going to grade it, and he's going to drop his head a little bit because you forgot to graph cosecant. Remember, sine helped me get to it. But now I'm ready to graph cosecant because everywhere this line touches the x-axis, every time is going to be a vertical asymptote. So we should end up with, what, 5 vertical asymptotes? And then I'm ready for my Lego hands. Lego hands. Again, on the Lego hands, they cannot cross the vertical asymptote. That will defeat the purpose of me making the vertical asymptotes if I'm allowed to cross them. And they need to come down and they need to touch every hill and valley. Hopefully mine did. And only the Lego hands are going to be solid because that's actually the only part of this graph that is cosecant. Everything else helped me graph it. Man, take a step back and look at your screen. Go show your mom and dad. Show them what you're doing right now in math class. I think they'll be proud. Maybe they'll be able to help you. I don't know. I know mine couldn't. Mine just taught kindergarten for 30-something years. They didn't do anything this hard there. All right, now's a good time to maybe take a break, go get yourself a bologna sandwich, can of SpaghettiOs, something, because I'm going to do all this again, except for this time with secant. So I'm going to continue on. If you need a break, go ahead, hit pause, come back, and you can finish your notes after your bologna sandwich. All right, so I'm going to be graphing secant right here. Same idea, guys. I'm going to act like I'm graphing cosine x instead. And so if you're foggy on just a basic idea of cosine x, please go back and watch the video I posted on cosine x, and it'll give you the basic shape. We're still going from 1 to -1. The only difference now is that I'm starting on the hill. Hopefully yours looks better than mine. That should be a good goal to have as we go through these. Am I good at that? That one hill looks a little bit weird, doesn't it? We're going to be good with it. And so this time, by the time I completed one hill and one valley, I landed, well, close, we'll say close to there, at 2 pi. Again, all these numbers came from you guys last week whenever you were helping me graph this. And what I'm going to do now is just realize that secant is just 1 over cosine x. So all of my same rules are going to apply. Everywhere where cosine x equals 0 is going to be a vertical asymptote. So all my vertical asymptotes are just going to shift pi over 2 units over. So instead of a vertical asymptote at 0, I'm going to have one at pi over 2, and 3 pi over 2, and 5 pi over 2. And negative pi over 2. Ooh, missed that one a little bit. Is that going to bother you? It's going to bother somebody. There we go. And 3 pi over 2. Okay, that should be enough. And I'm still just gonna draw my Lego hands right off these hills and valleys. They don't cross the hill or valley. They are what we call in math or geometry tangent to these hills and valleys. Period's the same, domain range same, but I want to talk about these isotopes. Isotopes are going to occur at every odd multiple of pi over 2. Meaning that if you throw an odd number in front of pi over 2, boom, there's a vertical isotope there. Now, we're not going to get lucky and probably get vertical isotopes exactly right here because I'm going to throw in a period change, a phase shift, something to throw it off. So I'm going to do another example. I think you know how it's going to go. I'm going to be using cosine to help me graph this secant function. I'm going to throw in some stuff, though, that hopefully helps you just understand the cosine graph better. And so I'm going to graph negative secant of 4x and then subtract off 3 from it. I took out the phase shift. So everything that I'm about to tell you is going to come out in my table. So it's got a negative in front of it, meaning that all of my hills and valleys are going to flip-flop over the x-axis. The 4 is going to make it so the period is much smaller, kind of like what the pi did last time. And then this negative 3 is just going to drop my whole graph down 3. That's going to play a trick on you when it comes time for the vertical isotope, but we'll get there. So I'm going to start off acting like this is just cosine instead. It's brother. It's reciprocal. We know it's reciprocal. And whenever I do that, I realize pretty quickly I'm going to need an XY table. Now remember, for cosine, it normally went from 0 to 2 pi. To figure out what my new table goes from, I'm going to take everything that comes with the x on the inside, the 4x, and set it equal to those two numbers. Got a little bit easier math on this one. I get x equals 0 and 2 pi over 4. Well, 2 pi over 4 is just pi over 2. I skip my amplitude and period. Amplitude's 1, period's 2 pi over 4. It's going to be pi over 2. I could divide that by 4/6 hour and go through. If you've been working problems that way, it's fine. And you're going to get pi over 8, meaning that I could just increase this by pi over 8 as I go down the graph until I reach my last number, which would just be pi. You guys not going to tell me I left off the 2? Pi over 2. Or I could play halfsies. Look at your unit circle. What's halfway between 0 and pi over 2? Boom, pi over 4. What's half of pi over 4? Pi over 8. So it just goes in order. 0, 1 pi over 8, 2 pi over 8, 3 pi over 8, 4 pi over 8. You need to get good at that table. That table is going to help you graph sine, cosine, cosecant, and secant. Okay, I'm ready to plug in now. So I'm going to take this 0 and I'm going to plug it in for this x. I'm still working with cosine for now. So 4 times 0 minus 3. Well, that's just going to be cosine of 0. Cosine of 0 is 1. You don't believe me? Look at your unit circle. I start right here at negative 4. Let's use our DHS easy button on this, okay? Negative 4. If you don't believe me, plug in pi over 2 in for that x, and you're going to end up with the exact same, in the exact same spot. You're going to end up with 2 pi, which is just the same as 0. All right, let's plug in pi over 8. Negative cosine of 4 times pi over 8 minus 3. Well, pi over 8 is going to just be negative pi. It's just going to be pi over 2. Cosine pi over 2 is 0. 0 minus 3 is negative 3. Here's a DHS easy button for cosine. These will have to be the same on cosine. So if you feel confident in your table, you can do that DHS easy button. if you're going to play Safety Steve or you're kind of questioning that table, you need to plug in all 5 of these values. I'm trying to get this video done, so I'm just going to play it, kind of play it safe right here, and or dangerous, I guess. So plugging in pi over 4. Plugging in pi over 4, I get negative cosine of 4 times pi over 4 minus 3. Let's just negative cosine of pi minus 3. That's a negative 1. Be extremely careful with those signs right there. So I'm ready to graph. I'm going to go ahead and mark on my axis. Yeah, I'm going to go ahead and plot these points. So 0, and I just naturally just skip 2. That makes it so, at least on my graph, it looks nice. And we got pi over 2. And I'm just going to count by 1s down here. I think that that's going to be good for me. So 1, 2, 3, 4. If you just count by 1s, you can still tell me you're counting by 1s, or I'll just assume you're counting by 1s if I don't see anything. And so this is just going to be a dotted line. And what I want to do is I want to extend this pattern through the next curve. I have to put dots there to help me realize where I'm going. There we go. And here's the problem this time, is my vertical asymptotes are going to lie everywhere that this cosine graph crosses the x-axis. Well, it never crosses the x-axis. But keep in mind, I moved everything down 3. And so a lot of people have success thinking of it this way, is that they're taking the x-axis and they're going to move it down 3 as well. That's that midline that some of you were asking me about last week, is what is that midline? It's just my new x-axis. It's just, if the x-axis came down with it, that is where it would land. And on top of that, what that means is that's where all my vertical asymptotes are. Everywhere this crosses, there shouldn't be one there. Everywhere, oh my. See the problem we have here? All right, let's throw that off. Everywhere it crosses this midline now, or this, I'm going to call it the fake x-axis, new x-axis, whatever you want to call it, that's where my vertical asymptotes are going to be. I haven't used green, and so I'm going to get my little hands, they're dipped down this time. Like I said, everything came out in the table as far as my period change and my vertical shift and even my reflection. You don't have to worry about doing any of those by hand. You can just look at your table. That's going to take some practice. All right, so here's your practice problems. Work on those. Let me know if you have any questions. If you do, I'll be glad to work as many of these as we can in class together. But of course, doing them on your own is going to help get you ready for the upcoming quiz better. Hope you guys have a great day. Stay warm, and I'll catch you guys next time.